Ever wondered why some winters are brutally cold while others are fairly mild? The answer lies high above the surface of the Earth in a phenomenon known as the polar vortex. This high-altitude, low-pressure zone holds key insights into our weather patterns and climate. It's not just about bone-chilling temperatures. Understanding the polar vortex gives us a glimpse into the intricate mosaic that is our planet's climate. So, are you ready to dive into the world of swirling cold air? Stay tuned to find out what exactly a polar vortex is and how it comes to be. To understand the polar vortex, we first need to know about our planet's atmosphere. Our atmosphere is a protective blanket of gases that shields us from the harshness of space. It's composed of several layers, each with its own characteristics and importance. Let's take a closer look. First, we have the troposphere, starting at the Earth's surface and extending up to about 10 kilometers. This is where we live, breathe, and experience weather. It contains about 75% of the atmosphere's total mass. The temperature in the troposphere decreases as the altitude increases. Next is the stratosphere, extending from the top of the troposphere up to about 50 kilometers. You might be familiar with the ozone layer, the Earth's natural sunscreen, which resides in this layer. Unlike the troposphere, the temperature in the stratosphere actually increases with height. This temperature inversion occurs because of the absorption of radiation by the ozone layer. Above the stratosphere, there's the mesosphere, thermosphere, and exosphere. But for our discussion about the polar vortex, we'll be focusing on the stratosphere. Now, you might be wondering why the temperature varies with altitude in these layers. It's all about the balance and absorption of solar energy. In the troposphere, the Earth's surface absorbs most of the sun's energy, warming the air near the ground. This warm air rises, cools, and eventually falls back, creating a cycle that drives our weather. In the stratosphere, however, the ozone layer absorbs the sun's harmful ultraviolet radiation. This absorption heats the stratosphere, causing the temperature to increase with height. This temperature inversion creates a stable, stratified layer with warmer air above cooler air. Understanding these layers and the temperature dynamics is crucial to appreciating the complexity of the polar vortex. It's not just a catchy term for a cold snap. It's a fascinating phenomenon that occurs in the stratosphere, directly influenced by these atmospheric conditions. Now that we have a basic understanding of the atmosphere, we can delve deeper into the world of the polar vortex. So, what exactly is this polar vortex? You might be wondering. Well, let's delve into the mysteries of this fascinating phenomenon. The polar vortex, in its simplest terms, is a massive whirlpool of frigid air that circles around the Earth's poles. Imagine a gargantuan cyclone, but instead of water and wind, it's composed of bone-chilling cold air. But how does it form, you ask? Well, it all begins with the Earth's tilt. The planet leans on its axis, resulting in one pole facing the sun while the other is shrouded in darkness. This leads to a stark temperature contrast between the sunlit hemisphere and the polar regions. This contrast drives the air to swirl around the poles, creating the polar vortex. Now let's talk about its structure. The polar vortex is not just a single layer of swirling cold air. It's a layered structure, a bit like an onion, with its main body located in the stratosphere, the second layer of the Earth's atmosphere. Here, the vortex spins leisurely, with winds moving counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. And remember, there's not just one polar vortex, there are two. One circles around the North Pole and the other around the South Pole. They may not always be equal in strength or size, but they are both vital components of our planet's climate system. It's important to note that the polar vortex isn't something that comes and goes. It's always there, swirling around the poles. Sometimes, we feel its impact more when parts of it break off and bring cold air to regions that aren't typically as cold. But the vortex itself is a permanent feature of our atmosphere. In essence, the polar vortex is a large area of low pressure and cold air encompassing the Earth's poles. It's an incredible natural phenomenon that plays a crucial role in our planet's climate system. So next time you hear the term polar vortex, you'll know exactly what it means. But how does the polar vortex affect our weather? This question often piques the curiosity of many, and rightfully so. Let's dive in, shall we? The polar vortex, a swirling mass of frigid air, is perched high above the poles in the stratosphere. It's not something that comes and goes. It's always there, but its strength and position vary. Now, during the winter months, this vortex can influence our weather significantly. Imagine the polar vortex as a large spinning top. When it's spinning fast, it's stable, keeping the cold air locked up in the Arctic. But when it slows down, it wobbles, sometimes sending chunks of cold air southward. This phenomenon is what we often experience as a sudden plunge in temperatures or a cold snap, especially in places like North America and Europe. Changes in the polar vortex can also lead to extreme weather events. When the vortex weakens, it can split into two or more swirling vortices. These smaller vortices can drift away from the pole, bringing bone-chilling Arctic air to regions that are usually much warmer. This is often the culprit behind those exceptionally cold winters that seem to come out of nowhere. But it's not just about the cold. The polar vortex also impacts the jet stream, the river of wind that carries weather systems around the globe. When the vortex is strong, the jet stream is more likely to flow in a relatively straight line. But when the vortex weakens, the jet stream can take on a more wavy pattern, causing weather systems to stall and linger, leading to prolonged periods of certain weather conditions, be it rain, snow, or dry conditions. So the polar vortex is not just a distant icy phenomenon. It's a key player in our weather patterns, particularly during the winter months. Its shifts and wobbles can mean the difference between a mild winter and one that is bitterly cold. Indeed, the polar vortex plays a key role in shaping our winter weather. One might wonder, what does the polar vortex have to do with climate change? Well, this icy whirlwind and our changing climate are more intertwined than one might think. As the Earth warms due to climate change, this warming isn't uniform. The Arctic, for instance, is heating up twice as fast as the rest of the globe. The result? A disruption in the balance of temperatures between the Arctic and the mid-latitudes, which can have a profound effect on the polar vortex. Typically, the polar vortex is a self-contained system with cold air swirling around the pole in a relatively tight circle. But as the Arctic warms faster than the mid-latitudes, it weakens the vortex. This weakened, wobbly vortex can then meander, allowing frigid Arctic air to spill southward. Think of it as a refrigerator door left slightly ajar. The cold air doesn't stay put, it seeps out, chilling the surroundings. Similarly, when the polar vortex weakens and meanders, it allows the Arctic's icy breath to sweep over parts of North America, Europe, and Asia, leading to periods of intense winter weather far from the pole. But it's not just about colder winters. A disrupted polar vortex can also lead to other extreme weather events, like heat waves in the summer, as the wobbly jet stream allows warm, tropical air to move northward. So, while it may seem counterintuitive, global warming can indeed lead to harsher winter weather in certain areas, all thanks to the disruption of the polar vortex. This is a clear example of how interconnected our global climate system is. A change in one area can have far-reaching impacts, rippling across the globe in unexpected ways. It's important to note that not every cold snap is the result of a wandering polar vortex. Weather is complex and influenced by many factors, but the trend is clear. As our planet warms, the polar vortex is becoming increasingly unstable, leading to more frequent and intense winter weather events. As the climate continues to change, we can expect the polar vortex and our winter weather to change as well. In conclusion, the polar vortex is a fascinating and complex phenomenon. We've journeyed through its essence, peeling back the layers of this high-altitude, low-pressure zone and how it sways our weather patterns. We've also delved into its connection with climate change, revealing the profound impacts of our actions on this atmospheric titan. Understanding the polar vortex is not just about bracing ourselves for the winter, It's about comprehending our planet's intricate climate system. Thanks for joining us on this icy journey into the stratosphere.